We're going to go ahead and take a look at number 45 from section 10.1 in your textbook, which covers solving quadratic equations using the square root property and by completing the square. Number 45 reads 6x squared minus 7x minus 5 is equal to 0. So bear in mind that there is a process behind completing the square, and the goal of completing the square is to create a perfect square quadratic so that we can factor it into the same binomials. So a product of two binomials where both binomials are the same. So to begin, one of the first things that we want to do is we want to make sure that the coefficient of the lead term is 1. So we're going to go ahead and divide each term by 6 so that these 6's will cancel out. The downside is that now we are going to have to deal with fractions, but that just makes it more challenging, not necessarily impossible. Okay, the next thing that we're going to do is we're going to clear this space where the constant is, and we're going to do that by adding 5/6 to both sides. Okay, essentially everyone kind of describes it as you're moving the 5/6 over, but really what you're doing is you're just clearing that spot, and in order to get rid of a negative 5/6, you have to add a 5/6 to it, a positive 5/6. Okay, so now we're left with x squared minus 7/6 x plus something, I'm just going to leave that space blank, is now equal to 5/6. Okay, so what we're going to do now is we will go ahead and complete the square. And in order to do that, focus your attention on the coefficient of the middle term that you have, or the term, the coefficient with just an x, or that's being multiplied by an x. So we take this negative 7/6, so bear in mind that I am taking the sign out in front of it with it. And I'm going to divide this by 2. Okay, so I can go ahead and change this into a multiplication problem by skipping the first fraction, flipping the other, or taking its reciprocal, and then making it a multiplication problem. This in turn gives me negative 7/12. And then we're going to go ahead and take this value that we got from having it, and we're going to square it. So we're going to get 49, positive 49 over 144. It's kind of gross looking, right? But trust me, it gets better. Okay, we found the term that should now go here, so we will add that 49 over 144 in this space, but bear in mind you are working with an equation, so you want to make sure that both sides stay equal to each other. So if you add a 49 over 144 to the left-hand side, you have to add a 49 over 144 to the left. Okay, so take a minute and make sure that these steps make sense or are clear. Okay, so let's get back to it. What we have done here on the left-hand side is we've created a perfect square quadratic. So if you were to factor this, and I'm going to show you the long way, this would be x minus 7/12 times x minus 7/12. And what I'm going to do is I'm going to go ahead and find a common denominator between 6 and 144. And actually what that is 144. In order to do that, you would need to multiply 6 by 24. So that means that we will multiply the numerator value, or the 5, by a 24, and that gives us 120 over here, and then we still have that 49 over here. Okay. So from here, we can go ahead and create a shorthand. So this is going to give us x minus 7/2 squared, because bear in mind, since I'm doing x minus 7/2 times x minus 7/2, I can consolidate that or shorthand it by just saying x minus 7/2 squared. Okay. One thing that I want you guys to note, once you do enough of these, you'll kind of pick up on this pattern, is the value that you get after you divide by 2, what I'm highlighting in pink presently, is that negative 7/2. Notice that this value is what goes into the last term's spot in your binomial. That's not coincidence, because if you think about it, your negative 7 halves reveals a lot of information. Negative 7 over 12 squared, pardon me, I gotta make sure that I am saying the right numbers, is going to give you 49 over 144, which is what we have right here. And also, if you do negative 7 twelfths plus negative 7 twelfths, that's going to give you negative 14 twelfths, which reduces to negative 7 sixths, which just so happens to be the value right here. Recall from class that we had done several of these perfect quadratics to show that pattern. Okay, so getting back to where we were, this then will be equal to 169 over 144. And here is where you can start to invoke your square root property. Okay, remember, the goal here is we want to get x by itself. We want to solve for that value. And we are successful in doing that by completing the square, because now, instead of having an x squared term and an x term, we just have x. We've consolidated it down. So what we're going to go ahead and do is take the square root of both sides. This causes the square to go away. So now I'm left with x minus 7 twelfths. And this is going to be equal to 13 over 12. And I did forget something, right? Most of you hopefully are thinking, I gotta put that plus or minus in there. Okay, so what I will go ahead and do is I will add 7 twelfths to both sides to get x by itself. And now we have two cases here, right? So we have a positive 13 over 12 plus 7 twelfths, or x could be equal to a negative 13 twelfths plus 7 twelfths. Okay, so then this means that x will be equal to 20 over 12, which we can reduce down to, what is that, 10 over 6. Oh, I didn't reduce it further down, so this is 5 thirds. And then the other one that we have, this will be x is equal to negative 6 over 12, which will reduce down to a negative 1/2. So what I'm about to circle in orange are my two solutions. Okay, so practice these a few more times. This one was definitely a little bit more tricky, especially since you were working with some heavy fraction values, and obviously they get more and more intimidating when you're squaring them. But this is your solution, and if you need any additional help, please come see me.